And let's talk about what we have just finished. We just finished chapter 19, and take a look at our picture over there of all of our things that we made about the true proportion of water on the globe. What were those called? What was it that we were making?
Confidence intervals.
Very good. We were making confidence intervals. So when we each made ourselves a confidence interval, what were we hoping to do with that confidence interval?
Get it close to the actual true number.
Perfect. We were hoping to estimate the population amount, the true proportion of water on the globe. So what we were doing with our confidence interval, estimating the true proportion of water on the globe. Okay, that is our parameter. In fact, let's take a look here. We were finding a range of plausible values for a parameter. I'm going to start using that word parameter pretty regularly, and so you have really got to solidify that in your brain that anytime I'm saying a parameter, I'm talking about a population value. Okay, so I'm talking about the proportion for the whole population or the mean for the whole population. So that word should just start becoming a regular word of our vocabulary as we talk through these things. Now, today we're getting into what is a hypothesis test. And the research is based off of hypothesis tests. For example, if you have a type of blood pressure medicine and you want to test and see if the different kind is better, then you will run a hypothesis test to see if the new and improved is significantly better than the original. And so we've got to learn this process of finding yes or no, it is significantly better or it's not than what it is originally claimed to be. So here we go. The very basics that we have to do is learn how to make a null hypothesis and what's called an alternative hypothesis. So we're going to learn how to make those two statements and learn the notation involved with those. So here's the first thing. The null hypothesis. So the null hypothesis is notated H with the little o, H naught. H with the little o is a null hypothesis. The way that you define, this is what I'm going to do. And a null hypothesis is a statement about a parameter, equaling, so it's always an equal to statement, a claimed value. So that would mean we would hypothesize that the proportion of water on the globe is, say, 70%. Then we're going to take tests and see if we have evidence to dispute that or not. So our statement is going to be about equaling a claimed value. Also, you may hear that this claimed value is called the hypothesized value. It's what they suspect that it might be. All right? Okay. So now, let's talk about alternative hypothesis. So this is notated H with the little a. Okay, so the null is the H with the little o, and the alternative is the H with the little a. So this is also a statement about the parameter. So let's start with that. It's a statement about a parameter. Okay, so this also is a statement about a parameter. And it is if it having a different value than what is claimed. Okay, so our alternative is a statement saying that the parameter has something different, about different value. So what it could be is things such as this. We could say that the parameter is less than or greater than or not equal to. So you don't actually say, oh, you think it's 47? Well, the alternative, I think it's 15. No, you don't make another statement of a number. You just say, I think it's less than 47, or it's more than 47, or it's not equal to 47. All right. Ultimately, here's kind of the goal of what we're headed for. So the goal is to see if we get a sample that is significant enough, and we're going to talk about that later today, significant enough to reject HO and go with HA. So we kind of, HO stands and HO holds, but we're going to take one single sample and see if that one sample is significant enough to reject their claim and go with HA, the alternative. All right, so let's practice these parameters, null hypothesis and alternative hypothesis. So here we go. Number 1. A car dealer advertises that its new subcompact model gets 47 miles per gallon. You assume that the dealer would not underrate the car, but you are suspicious about the claim. So first, is this a mean or a proportion problem?
This is a mean.
It is a mean. Miles per gallon is going to be your mean. So therefore, you start with the letter that represents population mean. What is that? Ooh, mu is the population mean. Mu with no subscript, okay? And you put mu equals, the first word should be average, because this is about an average. The average miles per gallon, the new subcompact model has. And this is all of those new subcompact models. So the average of all of those all of those cars that are the new subcompact cars. Okay, so now let me show you how you would write the null and the alternative hypothesis. So first I'm going to write HO colon. HO colon. All right, so don't forget this next little letter that I'm about to write. It's a common mistake that people miss. Okay, don't forget to write this. Ready? Mu equals 47 miles per gallon. Isn't that what the claimed amount is? Okay, very good. So now that's it for the null hypothesis. So alternative hypothesis, what are we suspecting?
We're suspecting that it's going to be less.
Yes. We suspect that they are overrating it, meaning they're saying it's much better than it actually is. So that would mean we suspect that the mu is less than, because that would be worse, miles per gallon. And that's it. Okay? Yeah. A lot of times, yes. Yes, ma'am.
Okay, I feel like this might be a bad question, but how did y'all know that that was a mean problem?
Okay, so the way we knew it was a mean problem is because like the miles per gallon is kind of a quantity that's continuous, you know, like it's not a proportion like 39 out of 47 or it's not categorical like the number of M&Ms out of 50 that are blue. You know, then you'd have to have the proportion that are blue. So that's how we knew it was a mean. Okay, let's take a look at the next one. Number 2, a package delivery service claims that it takes an average of 24 hours to send a package from New York to San Francisco. An independent consumer agency is doing a study to test the truth of this claim, since there have been several complaints about the company not meeting its delivery times. All right, So would this be a mean problem or a proportion problem?
Proportion. I'm sorry, mean. Yeah, mean.
Okay, it's going to be a mean, so my first letter is going to be mu equals the average. Okay, so that's what we're going to do. Mu equals average. Okay, now, let's talk about that. What do you think this is about?
The average delivery time.
Send a package. Hours to send a package.
The average time to send it from New York to San Francisco. But hold on, is that just all packages everywhere?
Package delivery service.
It's this particular service, right? Aren't we checking out the quality of that? Yes, because we're just caring about this particular service. They're disputing that. They're thinking this service is saying false claims. So we need to say the average delivery time
Should we say average package delivery time then? Otherwise, we could get maybe cars.
of a package from New York to San Francisco for this company.
Bless you.
Yeah, we're not just talking about delivering a package in general. We're seeing, is that particular company, actually slower than they claim?
Bless you.
All right. So write down what you think the null and alternative is. See if you can't do that right. Okay, so what did you put for your null hypothesis? Mu equals 24 hours. Okay, alternative? Greater than 24 hours. Very good. Okay, we do not need to do all of these examples. However, there are some things that I need to discuss with you on problems 5 and 6. So let's skip to problem 5 and 6 on the next page. Here we go, number 5. A team of eye surgeons has developed a new technique for risky eye operations to restore the sight of people blinded by a certain disease. Under this old method, it is known that only 30% of the patients who undergo the operation will recover their eyesight. Okay. But can we justify the claim that a new method is better than the old one? So what are we testing?
Proportion.
It's a proportion. But what are we checking out in this thing?
Whether or not it's better.
Whether or not what's better?
The new method.
New method. This problem is about the new method, not the old. That's not what we're talking about. So we're going to start this. I heard people saying as a proportion. So we start with the letter P equals proportion of patients who use the new eye surgery method. Patients who undergo surgery with the new method. That's just the denominator. The proportion of patients who undergo surgery with a new method, that's not all.
And succeed.
And recover their sight. That right there, that's an incomplete answer. That's a wrong answer. We're just not seeing who undergoes the new method. We're seeing who undergoes the new method and recovers their sight. All right. Ha ha. So there you go. Put your null and alternative hypotheses down, and then we'll move on. So do you see how it's important to really pay attention to what this problem is trying to say? What do we start with?
P.
Equals.
0.3.
So essentially I'm saying right there, hey, let's say the new surgery is equally as good as the old. That's what we're going to start with, unless you can prove to me that it is actually what? Better. Okay, so the null hypothesis is it's the same as the old one. The alternative is that it is greater than 30% of the patients, significantly more, gain their eyesight back. All right, let's do this one last one here. In 1990, 86.3% of the population of Cortland, New York was composed of New York State natives. Has that percentage of native New Yorkers changed since 1990? So what mean or proportion? Okay, so we're going to start P equals the proportion. So what do you think this is about? Proportion of
native-
what's our
native New
denominator?
Yorkers.
Cortland, New York.
Think, what's your denominator? Is your denominator all native New Yorkers, or is your denominator something else? Cortland, New York residences. Good. You have to think, what is your denominator? So it's the proportion of Cortland, New York residences who are native New Yorkers. See, present tense, remember that? We're taking that sample from the okay, so now, null hypothesis would be that what? P is still the same as it was. So you can write it as a decimal or as a percent. It doesn't matter. Okay, what do you think the alternative is?
P does not equal 86.
Oh, good job. P, it did not indicate we think it's greater or we think it's less than. So therefore, we are checking to see if it has changed. It is not equal to 86.3%. Okay, now, your assignment is the next 2 pages, which is 8 of these, and I'm going to give you about 10 to 12 minutes to work on that, and then we will start on a head start on the next lesson's notes.